Welcome to this video assignment PDE3432 on robotic manipulators and Labview modeling. The aim of this project is to understand the principles of robotic manipulators and the ability to model manipulators using Labview. As you may know, robotic manipulators are widely used in various industries, which manufacturers and constructions to healthcare and entertainment. To operate and control these complex machines, we use sophisticated software and programming tools such as Labview. In this assignment, I have learned how to model a robotic manipulator using Labview and apply the principles of kinematics and dynamics to analyze its motion and behavior. By completing these assignments, I will demonstrate my skills in robotics, programming, and data analysis, which are essentials for many careers in the field of engineering and technology. So, let's start and learn more about robotic manipulators and Labview modeling. Labview has two main parts, the front panel and the block diagram. The front panel is a graphical user interface GUI that allows users to interact with the program and provides a visual representation of the data being processed. It consists of various controls and indicators that can be customized to suit the specific needs of the program. On the left hand side, there is a black square which represents a 3D model of the robot. On the right hand side, there is a tab control where we can view my student information and the tasks of the assignment. Let's navigate to the second tab called Movement Simulator. This program will demonstrate the use of manual left, right, up and down buttons and automatic functions to control the robot. We can also adjust the speed of the robot movement using the horizontal pointer slide. Also monitor the values of the end effector transform and the current joint positions. The manual mode, we can view the X and Z values to help accurately position the robot based on the specific requirements of the application for future development. Okay, so now let's navigate to the block diagram of the Labview program. Let's first define what's block diagram and what it does. Okay, so the block diagram is where the user designs the code or algorithm that will be executed by the program. It contains various functions nodes, structures, and wires that represent the flow of the data and control in the program. Cool. So let's start with here. Which one is the definition of the arm and the types of the joints? As we can see here is how this could be the rotations, and in the third column we can see the length of the robot that it shows previously in the simulation of the arm robotic. Okay, so this data they will send to the type of the robot, which type of robot we want to use, and for this project we are using the initialized generic serial arm. Then they send the data to the plot, which one initialize the 3D object that represents the robotic arm. And on the other hand, we have the origin position of the joints, which we can see exactly how is the values between them. Okay, so all this data that we have previously about the robot arm, let's go to the big while loop that we can see here. So let's start from here. All this data that I explained before, they go through the first part, that is the forward kinematics, that transforms the current joint angles, position of the robotic arm of the n effector relative to the base of the arm. Then they have here the get translation vector, which one they send the data to the index array, which obtain the x, y, and z parameters from the translator vector and alterate the values. And how this alterates is depends of the how we want to use. We have here as a manual or auto button that we can change. If it's false, it will be manual, but if it's true, that will go to the automatic mode. Okay, so let's go first to explain how works the manual mode. So that we have the three parameters x, y, and z. We have x first and then the z. All the operation that we can be using depends of the buttons that we are available to use. For this case, we have 4 buttons, that is left, right, up, and down. We have z, x will be left or right, and the z for up and down, and y will be 0. Okay, so this is the operation that we have to use for left or right. And here we have how's the limits between the maximum for left, maximum for right, and maximum for up and down. We write down here the values that is the maximum that the robot can reach, and then send the data to this transform, which one create the translations. Okay, and then from here they send to the first for loop. So now let me explain you the automatic mode, how it works. So we have different letters that we can see on the right hand side. That's 1, 2, 3, 4, 5, 6, 7, 8 points that will be using x, y, and z values. We have y, which one is 0, so I take this 0 as a whole 7 for all the points, so it's the same value. So for reason is here, so you have only x and Z for every single point. So how this works and what that means on what's the meaning of this in the simulation is in the second slide. So all these points, they go to this build array, and then this will go to the for loop as the manual mode. Okay, so let me show you where is these points in a simulation. Okay, so as how you can see here is there are different points, that the values that I showed you before, the A, B, and C until H. So the robot will start from the point A, and then they will pick up the object from point B, and from leaving the shelf, the first shelf will be go to C, and leave the object or pick up the object from there will be D, and then the second shelf will be E, leave F, and take G, and leave H. Everything between them, there's the same separation between G to E, and from E to C, and from C to B. Okay, so now let's go to the final part of this part, the project, from the block diagram. Let's start from the first for loop, which all the information that we have before, using the manual and automatic mode, the signals and data that we have before. So all the data go to the second forward kinematics, then they will go to the generate Cartesian trajectory, which generates a smooth trajectory of end positions between 2 points in the Cartesian space. And this is controlled by this speed moving robot, which one there will be using the horizontal slice that we can be able to change in the simulation part in the front panel. Then all this information, they go to the second for loop and final loop, which all the data that will go to the transition along the X, Y, and Z axis, while disabling rotation for the reason that the zeros. Then we can see two main things that is in the front panel, that which one is the n effector transform and the current joint points. This n effector transform shows the homogeneous transform that represents the position of the n effector relative of the arm base, for the reason that we can see in this matrix. This is the maximum number of steps that we are using right now for this simulation. It will be go to the inverse kinematics. Then we'll go to the initialize plot, which one initializes in 3D the object that represents robotic arm. Then they will go to the update plot, which one they will update after go to the inverse kinematics, and this will show in the 3D picture that we can see in the black square that we have in the front panel. And finally, of course, we have the stop button that probably we use later on or further stages of the program. Yes, so as you can see, I explained all the parts from the beginning of the how to design the robot, how it's controlled using the manual and automatic mode, and then how we using the control speed, and how go from forward kinematics to the inverse kinematics, how update the plots, and finally simulates the robot.